Okay, hello and welcome everyone. In this video, I'm going to do a walkthrough of some Cournot Oligopoly problems. This is like one Bertrand, identical products Bertrand question. There's a Stackelberg question, and these are all like past exam problem set type questions. So, all right, the first one, there's only one Dairy King, in Arlington, Nebraska, which is a lie. There is no longer a Dairy King. There's no longer ice cream in Arlington, Nebraska. So suppose the market inverse demand is price is equal to 15 minus Q. The firm has constant marginal cost of 3. Suppose we have an identical firm opened up and they compete as Cournot firms to serve the market with their joint quantity selection being the market quantity. We want to know how much in which direction do the profits of the original Dairy King change? Well, clearly the profits have fallen with entry. Like that's what happens. Let's start off though with the monopoly outcome. Then we'll compare that to the Cournot outcome. All right, the monopoly outcome, monopolist is going to produce where its marginal cost equals its marginal revenue. So marginal revenue is going to be 15 minus 2Q, right? Same vertical intercept, but twice the slope gives us the marginal revenue curve from our inverse demand. Set this equal to our marginal cost of 3, and then solving, 15 minus 3 is 12, divided by 2 is 6. Plug this into the demand curve. Prices come from demand curves, so 15 minus 6 is 9. So our monopoly profits, 9 minus 3 is the markup times 6, so 36 overall. For Cournot, we now have two firms. They're identical. You might wonder, like, how do we model firm 2? Well, firm 2 is identical, so it's going to have the same costs. All right? So that'll come up later. Here is firm 1's profit as a function of their own choice. So this right here, price times quantity, this is revenue, minus cost times quantity. This is total cost or total revenue minus total cost, which means our first order condition gives us marginal revenue minus marginal cost. Okay, so first what I'm going to do is I'm going to distribute this Q and then simplify. So I've got 15Q1 minus 3Q1 is 12Q1. Q1 times Q1, Q1 squared. Q1 times Q2 is Q2Q1. Take the derivative, I'll have 12 minus 2Q1 minus Q2 is equal to 0. Solving for Q1 gives me firm 1's choice as a function of firm 2's choice. This is firm 1's best response to firm 2's quantity choice. Whenever you have something that looks like this, this is their general form kind of for our Cournot. This is our form for our Cournot best response function. Actually, the more general, for coefficients of 1 right here, the more general version would be A minus C minus Q2 divided by 2. When you have something like this, whatever is the coefficient, whatever is your A minus C, right? 15 minus 3 is your A minus C portion. I would just do this division, right? This is 6 minus 1 half Q2, and then I'll simplify the math. So here is firm 1's reaction to firm 2's choice, just kind of written a little bit different. And by symmetry, I just backed out what must be firm 2's choice as a function of firm 1's selection. We know that because they both are identical firms. They're identical. Here's their costs. Okay. So now I've got a system of two equations and two unknowns. I'm going to plug one into the other. I'm actually going to plug this expression for Q2 in for Q2 here. Right. Notice this is Q1 of Q2. It's not multiplication. This is function notation. So now I'm going to accept the fact that firm 1's choice is a function of firm 2's choice. Let's put firm 2's choice in there. So now we've got a statement all in terms of Q1's. We'll distribute this minus 1/2. That's going to give us a minus 3. Distribute the minus 1/2 here. That gives us a plus 4, plus 1/4. Move that to the other side. That ultimately give us a 3/4. So here 6 minus 3 is 3. Boom, boom. Cool. Got it. So we're going to have, let's see, 4 times 3 is 12, divided by 3 is 4. Q1 is equal to 4. Let's check our best response functions to make sure they're working, make sure we haven't made a mistake. 6 minus 1/2 times 4, that's a terrible 4. 6 times 1/2 times 4. 6 minus 1/2 times 4 is 4. Cool. So our market quantity is 8, so our market price 7. So our profits are going to be 7 minus 3 times 4, or 16 for each firm, 32 overall. How does that compare to the monopoly profits? Lower, right? So in which direction have profits changed? They've reduced. By how much? Well, so profits used to be 36. Now they're 16. So they reduce by 20. Okay, so we've got this all right here. Yep, that's right. Here's another one. So there's only one Dairy King in Arlington, Nebraska. There used to be only one Dairy King in Arlington, Nebraska. Suppose our inverse demand is 18 minus Q. The firm has constant marginal cost of 3. Suppose an identical firm opens. By how much and in which direction do the profits change? Well, this is the same question. Just raise this from 15 to 18. So here's the monopoly solution. 18 minus Q times Q minus 3Q. Right, so I actually wrote out the profit function. You could distribute this. You get 18Q minus Q squared. Take the derivative. You'll have 18 minus 2Q, right? Marginal revenue has the same vertical intercept, twice the slope. This will actually give you the calculus to get that. Right, what's this 15 doing there? That was the marginal cost of 3. So 18 minus 3 is 15 minus 2Q. So monopoly quantity is 7.5. If the monopoly quantity is 7.5, monopoly price is 10.5 because 7.5 plus 10.5 is 18. And monopoly profits are 74.25. In the duopoly case, well, let's just redo the problem from before. Now taking the perspective of firm 1 where rather than 15, the vertical intercept is 18. The first order condition is then going to be 15 minus 2Q1 minus Q2. Our reaction curve, rather than being 15 minus 3 or 12 minus Q2 is now 18 minus 3 or 15 minus Q2 over 2. Here's by symmetry, here's our reaction curve for the other firm. Solving the system of reaction curves, we get 5 is equal to Q1. Let's plug this into our reaction, make sure that works. 5 is equal to Q. That should be 5 is equal to, 5 is equal to Q1. Let's plug this in here. 15 minus 5, 10 divided by 2, 5, right? So we do indeed have an equilibrium. Both firms will set a quantity of 5. And then the price here is going to be 8. Why? Because the market demand is going to be 18 minus the joint quantity of 10. So price is going to be 8. And then profits are 30 for each firm. So what's going to happen? Well, profits are going to be lower. And by how much? Well, 74.25 minus 30. So they're going to be lower by, 44 and a quarter. All right, consider a market with inverse demand 100 minus 2Q. Firms have no fixed costs and constant marginal cost of C. Derive the firm's output and profits when served by Cournot duopolists. This one I'm going to write out. There's kind of an interesting algebraic exercise to get here. I was a little bit clever, and so I'll walk through that. This place where people might have questions. So, all right, here is our market demand. Here is our marginal cost. So firm 1's profits is going to be 100 minus 2Q1 minus 2Q2, this whole thing times this quantity, minus CQ1. Now what I'm going to do is I'm going to distribute and collect like terms. So this 100 minus C is going to be from this 100Q1 minus the CQ1. That's what this is doing. Distributing this Q1, I'm going to get minus 2Q1 squared. And then distributing the Q1 here, I'm going to get minus Q2Q1. Taking a derivative, I'm going to get 100 minus C. Then I'm going to get 4Q1. Then I'm going to get 2Q2. Solving for Q1, I'm going to have 100 minus C minus 2Q2, the whole thing divided by 4, gives us firm 1's choice as a function of firm 2's choice. So by symmetry, because we do have symmetry here, right? Inverse demand firms, this is going to be 2 multiplied by the market quantity. So it's 2 times Q1 minus 2 times Q2. And then they both have the same marginal cost. So we've got symmetry here. So I know firm 2's reaction to firm 1's choice is just this. We have a system of 2 equations in 2 unknowns. Let's plug one into the other and solve. That's what this is doing here. So 100 minus C minus 2 times the quantity 100 minus C minus 2Q1, whole thing over 4 equals 4. Or equals 4, divided by 4. Now the place where you have to be clever, you have to be careful, is as you're multiplying through, you have to make sure you're distributing to everything. All right, so immediately I'm going to have a 4Q1. Then I'm going to have minus 100, or 100 minus C, minus, what's going on here? So I decided to conserve space and distribute this kind of all in one step. So what did I do? Well, this is going to be 100 over 2. This is going to be a C over 2. And this is going to be a 2Q1 over 2. So what on earth is going on? Well, if I distribute this 2 through, or if I think about what this 2 is doing, it's going to cancel off of this 4. So I'm going to get 100 over 2. I'm going to get a minus c over 2. And then I'm going to get 2 over 2. Right? Okay, so then this is going to be 4q1 equals 100 minus c minus 50 plus c2, or c over 2, plus q1. Collecting like terms, so this is going to be 100 minus 50 is 50. This is going to be minus c plus a c over 2 is going to be a minus c over 2. Moving this to the other side, I have 3q1. Then solving, or dividing both sides by 3, I have this divided by 3. And then I'm like, wait a second. I don't really like having this 50 minus c over 2. So why don't I be kind of clever and multiply through by an extra 2. I can't just multiply the numerator by 2. I've got to multiply numerator and denominator by 2, because if I do that, that's just 1 written really cleverly. So if I multiply this by 2 over 2, the 1 2 goes to the numerator, so I'm going to distribute. I'll have 2 times 50 is 100, 2 times minus c over 2 is minus c, and then one of the 2's from my 2 over 2 goes to the denominator, that's my 6. Okay, very good. So this is going to be our Cournot equilibrium quantity. With the Cournot equilibrium quantity, we can then get our profits. All right, so I did this down here. First, we have to get our price. So price is going to be the 100 minus 2 times that quantity minus 2 times this quantity. This is this is Q1, this is Q2, right? Anyway, so as we're recognizing this is the same thing, so this is just 4 times this stuff. Now I can multiply this 4 through and then cancel some stuff. So this is ultimately, what did I do? No, I canceled first, didn't I? Yep, I canceled off a 2 here to make this 3. And then I had 1 2 to donate to both. So this became minus 200 plus 2c. Why? Because this is a minus 2 that I distributed. Good. So I've got 100 minus this stuff. And then I said, wait a second, I can write 100 clever also. I can write that as 300 over 3. And if I do that, I've got common denominator, so I'll have 100 plus 2c over 3 is my price. If that's my price, then my profit is going to be that price minus marginal cost times the quantity. Okay, so I'm again going to write this cleverly to have the common denominator. So I write this as 100 plus 2c over 3 minus 3c over 3. Good. So that's going to give me 100 plus 2c minus 3c over 3. Or 100 minus c over 3. So then what I'm going to do is I'm going to say, wait a second, I can do something else to get a common denominator. I've got a way to make this a 6. So if I multiply again by 2 over 2, one of the 2's is going to go through and make this a 6. So then I'm going to have 100 minus c over 6 twice, so squared. And then the other 2 stays out front, right? Because what I did is I multiplied by 2 over 2. And so this is the numerator 2, the denominator 2 justified making this a 6. And so then my profits are 2 times 100 minus c, that quantity squared, divided by 36. And that was what this was doing. So this is saying, what was this doing here? So use the profits of the... Okay. How do outputs vary with C? Output and profit vary with C. Specifically, use calculus to find the derivative of each output. Okay, so once we've got the profits, then we can take the derivative with respect to C. So if we take this derivative with respect to C, right, this is going to be, well, this will be a 2 times this is going to be a 4, and this is going to be times a minus 1, so we'll have a negative, right? So yes, I was doing this one. So we'll have a minus 4. I should do this more carefully. So we'll have this 2 times, we take the derivative here, chain rule, so this will be 4, reduce this by 1, and then we'll have the minus 1 here, so this will be negative 4 times this stuff divided by that. So that is why the derivative does this. What did I do there? I don't know. Did something. Yeah, profit is this. So the derivative, I don't know. The important thing for the derivative is the sign. I have to go back, but the important thing for the derivative is the sign being negative. So we were interested. So it's saying, how does profit vary with C? Yeah, it's decreasing in C. We don't need calculus for that, right? You should know that if higher quantities, higher costs, we're going to have a lower profits. Right. And then how's the output vary with C? Same thing. So then we just differentiate this with respect to C, and that's going to be minus 1/6. Yeah. Oh, I know. I'm a fool. So yeah, so I've got this third. If you go back, then it works differently for the profits. Okay, whatever. So here's Cournot Oligopoly. There's 2 ice cream vendors in Arlington, Nebraska. Actually, there's none. Suppose the market inverse demand is 12 minus Q. One vendor has constant marginal cost of 2. Suppose the second vendor opened up later and the labor market is thin. There's very few workers. So the original vendor has a first mover advantage. It can employ a more efficient staff. Therefore, the second vendor has a higher marginal cost. Suppose they compete as 2 Cournot duopolists. This is just a long way of saying that you've got to compute the reaction curve separately for each firm because they have different marginal costs. All right, so here's the first one. So firm 1's perspective, here's the inverse demand times their quantity minus their cost. Distributing and then taking our derivative, I'll have 10 minus 2Q1 minus Q2. Solving for firm 1's choice as firm 1's quantity as in response to firm 2's quantity, it's going to be 100, or it's going to be 10 minus Q2 divided by 2. Now I'll redo the problem from the perspective of firm 2. What changes? The cost portion. All right, so I have 12 Q2 minus 4 Q2. That gives me this 8 when I take my derivative. This gives me a Q1, and this gives me a 2 Q2. Solving, I'll have 8 minus Q1 over 2. I've got a system of 2 equations in 2 unknowns, so I can substitute one into the other and then solve for the optimal quantity. That's what I did here, solving. So plugging one into the other, did this, and this boils down to an optimal quantity of 4 for firm 1. What about for firm 2? This boils down to an optimal quantity of 2 for firm 2. We better check those. So if firm 1 is setting a quantity of 4, what's firm 2 going to want to do? Let's use firm 2's reaction. So let's plug 4 in here. 8 minus 4, 4 divided by 2, 2. Good, that fits. Let's use firm 1's reaction, firm 2's choice. 10 minus 2 is 8 divided by 2 is 4. That's this. All right, and then the price is going to be 12 minus 6 or 6. Find the profits when they produce as Cournot duopolists. So find total producer surplus. So profits are going to be price times quantity minus cost times quantity. Actually, it does right. Price times quantity, or quantity times price minus quantity times cost. Either way, profits are 14, and then here profits are 4. Total market profit is 20. Total market quantity was 6. So Arlington is naturally prone to small town politics. Suppose the original ice cream vendor wishes to take advantage of this. What arrangement might they make to make both vendors better off while incentivizing the second vendor to stay out of the market? This is super illegal, but like, what kind of collusive agreement could they come to? Probably what would happen is one firm would buy the other one and then just kind of shut them down. So, right. But anyway, so what I want to do is assume the low-cost firm serves the market. So let's calculate their monopoly output, or their monopoly problem. So firm 1's a monopolist. It's going to face the entire market demand. So this is firm 1's monopoly problem, right? This is price times quantity minus cost times quantity. So this right here gives us, well, this is a simplified version. This is the first order condition after I simplified. So I have marginal revenue is equal to marginal cost, and so the optimal monopoly quantity is going to be 5. The monopoly price, 12 minus 5, is going to be a price of 7. 35 minus 10 is going to be a profit of 25. So this is just saying, like, in equilibrium, this is saying that if firm 1 served the market as a monopolist, their profit would be 25. If they compete as Cournot duopolists, their profits are 16. Market surplus as Cournot Oligopoly is 20, but market profits as a monopoly is 25. So the logic is just like, well, if I'm firm 1, why don't I just buy firm 2 for 4? Give them their Cournot profits. They'll agree to it because that's as much as they'd get as a duopolist. And so then they'll stay out. They'll produce 0. We kind of like buy their stuff and just put it in a warehouse their capital or sell it off or whatever. And then, so that'll be like the lower bound on a transfer that firm 1 would make to firm 2. What's the upper bound? Like what's the highest price that firm 1 would be willing to pay to get firm 2 to shut down? Well, firm 1 wouldn't want to pay any more than 9. Why? Because 25 is their monopoly profits minus 9 is 16. If they paid 10, then they'd be at profits as a monopoly and then paying 10 to buy the other firm. Then their profits would be 15, which would be lower than they'd get as Cournot duopolist. So that's why I say in equilibrium, firm 1 would produce 5 units. That's the monopoly output. Firm 2 would produce nothing. They've been bought out by firm 1. To keep firm 2 out of the market, firm 1 transfers somewhere, some amount greater, or at least as big as 4, no larger than 9 to firm 2. Firm 2 is able to make a profit of 4 by producing Q2 as a duopolist. Now they're indifferent if they get at least 4. Okay. So Bertrand oligopoly, consider the following market structure. So here's our market demand. We have a market price. Q is the aggregate industry output. Suppose your firm has constant marginal cost of 200 and your rival's marginal cost is 500. Suppose we have Bertrand competition. Find the market price and output of each firm and the firm's respective profits. Well, they have different marginal costs. Our identical products Bertrand involves price going all the way down to marginal cost. So you might think the price is going to go down to 200, but it doesn't need to. The price only needs to go to 499 or 500 minus some epsilon such that firm 1 is able to undercut firm 2. So firm 1 is going to operate like a monopolist. So if they had symmetric costs, so if costs were both 500, the price would be 500. If costs were both 200, price would be 200. But here they have different costs, and so price gets driven down to 499. Why? Well, because that's or 500 minus some epsilon, where epsilon's small, because that's the most profits that the low cost firm is able to extract while keeping the other firm out of the market. So so the rival produces 0 for 0 profit. Your profit, price minus cost times quantity. So 500 minus epsilon is approximately 500. Minus cost of 200 times the 1,000 units is the 3,000. All right. So here's another one. So suppose our inverse demand is 100 minus Q1 minus Q2. QI, that's the quantity bought to the market by each firm. Firm 1 has these costs, their marginal cost is 10. Firm 2 has these costs, their marginal cost is 40. Find the Cournot outcome, find the stable collusive agreement where one firm could incentivize the other firm to stay out of the market or just be like the price you could buy out the other firm. Rather than collusion, suppose firm 1 moves first, so firm 2 is left to serve only the residual demand. Find the quantities each produces in equilibrium and comment. This is the Stackelberg one, right? Firm 1 moves first, they're the leaders. Firm 2 follows. All right. So the solution, Cournot solution, first find firm 1's profit maximization problem. So here's the inverse demand, their quantity, there's their cost. The first order condition is going to be, well, distributing this would be 100 Q1 minus Q1 squared minus Q2 Q1 minus 10 Q1, or 90 Q1. Take the derivative, that's 90. Q1 squared, derivative 2Q1. Q2 Q1, take the derivative, that's just Q2. Solving, we have firm 1's reaction to firm 2's choice. It's 45 minus 1/2 Q2. Solving firm 2's problem, everything's the same except for cost, right? We don't have symmetry, so we actually have to do this. And we find firm 2's, if we see this is 100 minus 40, gives us 60 Q2. Take the first order condition, that'll be 60. This was a Q2 Q1, that's just Q1 after the derivative. This is Q2 Q2, or Q2 squared. Take the derivative, that's 2Q2. So firm 1's reaction was 45 minus 1/2 Q2. Firm 2's reaction is, I should have wrote 2. So firm 2's reaction, clearly, right? This is Q2 of Q1. Firm 2's reaction is 30 minus 1/2 Q1. Substitute one into the other and find the Cournot equilibrium. And so that's going to be 40 40, and then for firm 1, and then for firm 2 it's 10. Did I do that one? I must not have done it. Okay, sorry. So let's just verify this. So this is just algebra, right? So you're replacing. So going up to firm 1's reaction curve, rather than writing Q2, you're going to write the quantity 30 minus 1/2 Q1, right? Let's verify this is correct. So if firm 1 produces a quantity of 40, what's firm 2 going to do? 1/2 times 40, 20. 30 minus 20 is 10. So that works. Let's verify what firm 1's going to do if firm 2 produces 10. So 1/2 times 10 is 5. 40 minus 5 is 40. Okay, so this is our equilibrium. Equilibrium price is going to be 50. 100 minus 40 minus 10. Profits are going to be 1,600 to firm 1. For firm 2, it's going to be 100. This is price minus marginal cost times quantity. Price minus marginal cost times quantity. Okay. Firm 1's more efficient, so they'd be the one who'd do better as a monopoly. So let's find the monopoly profits for firm 1. Well, as a monopoly, firm 1's going to produce a quantity of 45. Their price would be 55. Monopoly profits are just going to be 20-25. Firm 1 can pay firm 2 to produce nothing. They can buy them out, or they can collude, which is super illegal. So the antitrust regulators would get them, but if they did, they could at least make the other firm want to stay out. So this would require a transfer. Transfer would be somewhere between 100 and 425. So the story is we need a minimum of 100 to keep firm 2 indifferent between producing and not, because their Cournot profits were 100. So if they stay in the market, they'll get 100. We want to keep them out, and so we'll pay up to 425. Why? Because after paying 425, deduct 425 from 1225, our profits are lower as a monopoly that's buying out the other firm than they would have been in Cournot, getting 1,600. All right, so C is Stackelberg. This is where one firm moves first and the second firm is left to serve only the residual demand. Stackelberg amounts to first solving at the back with the follower. So find the follower's reaction curve, then putting the follower's reaction curve directly into the leader's profit function. So what I've done is I wrote out the leader firm 1's profit function as 100 minus Q1 minus Q2. Oh, but we know what Q2 is. Q2 is a function of Q1. It's firm 2's reaction curve, right? So I took firm 2's reaction curve and I plugged this in to firm 1's profit function. Why? Because firm 2 is observing what firm 1 has chosen, and firm 1 knows this. So firm 1 knows that however they change Q1, that's going to affect Q2. So let's bring this right into our optimization problem. Sure enough, we can distribute. So this will be 100 Q1 minus Q1 squared minus 30 Q1. Distribute this minus. That'll be plus 1/2 Q1 minus 10 Q1. Now we take a derivative. Well, clean this up and take a derivative. It'll be 60 minus Q1 minus 1/2 Q1, or Q1 is equal to 60. Q2 is then equal to 0. Why? Because if we plug Q1 into the reaction curve, we'll see 30, the optimal selection as a function of Q1. If firm 1 produces 60, firm 2 gets 1/2 times 60, that's 30. 30 minus 30 is 0. Firm 2 doesn't produce anything, right? So as in part B, we get the same result. Firm 2 doesn't produce anything, but firm 1 actually likes Stackelberg better when it lacks bargaining power. Also, it's not illegal. And the collusive shutdown decision is better when it has more bargaining power. So, all right, that was great. So my contacts I'm super blurry, so I kind of remember these problems, so I kind of see them, I kind of can't. Which is amazing. So like a lot of times at the end of the day, so teaching class in the afternoon, I just stare out at just a blur, and I probably should take the contacts out. It'd be just as good, or use glasses, but whatever. So, all right, suppose a firm has estimated their market demand is 160 minus 2Q. Marginal cost is 40. They know they're the first in the market, definitely be the sole firm for the first year. The second firm is highly likely a rival want to enter the market, maybe a former roommate. If this happens, they'll split the market as identical Cournot oligopolies, solve for the monopoly outcome and profit. Solve for the Cournot oligopoly and profits, and do Stackelberg. All right. So the monopoly is going to be just produce where marginal revenue equals marginal cost. Okay, if this is price, or if this is inverse demand, marginal revenue has the same vertical intercept, twice the slope. So marginal revenue is going to be 160 minus 4Q equals 40. Okay, 160 minus 2. Why did I do that? This is supposed to be 160 minus 4Q is equal to 40. So 160 minus 4Q, so that's going to be 160 minus 40 is 120. 120 divided by 4 is 30. Yeah, so this is right. Okay, so good. Good, right. So this right here needs to be a 4, but this is correct. Okay, so then the price is going to be 100. Profits are going to be 100 minus 40 times 30, or 1,800. So monopoly profits are 1,800. Let me actually verify this price. So this is going to be 160 minus 60, right? 2 times 30. Okay, so that price is correct. Yep, so this is all right. Very good. All right, so let's do Cournot. So you might look at this and say, like, wait a second, how do we find the Cournot? How do we find the inverse demand for this? This is 160 minus 2Q. How do I deal with that Q? Remember that Q is the market demand. That's the sum of Q1 and Q2. So our inverse demand is going to be 160 minus 2Q1 minus 2Q2, right? This is 2 times the sum of Q1 and Q2. Multiplication is commutative and associative. So I'm going to write this as 160 minus 2Q1 minus 2Q2 times Q1 minus 40Q1. All right, so we'll take the derivative. So it'll be 120. That was from this 160 minus 40. So 120 minus 4Q1 minus 2Q2. Firm 1's reaction to firm 2's choice is 30 minus 1/2 Q, or Q2. By symmetry, do we have symmetry? Yeah, we have symmetry. Why? Because this is 2, which is going to be multiplied by both Q1 and Q2, and they have the same marginal cost. So we have symmetry. By symmetry, we know firm 2's reaction curve is going to be 30 minus 1/2 Q1. Plugging one into the other, we'll solve the system of reaction curves. So rather than having Q2 here, I'll just write 1/2 times the quantity 30 minus 1/2 Q1. Solving, we'll find the optimal quantity is 20. Let's verify. 30 times 1/2 of 20, or 30 minus 1/2 times 20 is 10. So 30 minus 10 is 20. Got it. So then we'll have our price is going to be 160 minus 40 minus 40, or 160 minus 80 is 80. So profits are going to be 80, price minus marginal cost, so 40 times 20 is 800. Total profits are 160. All right, so profits are way lower in Cournot than they were for our monopolist, right? They're lower jointly in the market than they were for the monopolist too. Stackelberg is like Cournot, but we replace Q2 with Q2 of Q1 because firm 2's strategy is actually a function of Q1, and because firm 1 knows that firm 2 is observing firm 1's choice when they're making it. So they know that their choice is influencing directly what the follower is going to do. So I'm going to write out firm 1's profit now as 160 minus 2Q1 minus 2 times the quantity 30 minus 1/2 Q1. Well, this is just firm 1's firm 2's reaction in terms of firm 1's choice, and this is the quantity minus 40 Q1. So this right here looks just like this. Looks a lot the same. What's the difference? Rather than Q2, I'm going to insert firm 2's reaction to firm 1's choice. All right. So then what I'm going to do is I'll distribute and then expand. So I'll get 160 Q1, right? This is distributing this to here, minus 2Q1 squared, minus 60 Q1 plus, well, this minus 2 times minus 1/2 is plus 1 Q1 squared, minus 40 Q1. So this is really nice to clean up because this is just going to be what 160 minus 60 is 100, minus 40 is 60. Take the derivative, that's just 60. And then I'm going to have a minus 2Q1 plus a Q1, or minus 2Q1 squared plus Q1 squared. So this is going to be just minus 2 or minus Q1 squared. Taking the derivative, I get 60 minus 2Q2 or 2Q1. And so we find the quantity is 30, which we already knew. Why? Because our Stackelberg leader is going to produce the monopoly output when we have the symmetry like we do in the Stackelberg problem. What does firm 2 do? Firm 2 is going to produce, there's going to see this output of 30. We'll put this into the reaction curve. 30 minus 1/2 of 30, oh, that's 15. So the profits are going to be 160 minus 60 minus 30, which is going to be, this is price. 160 minus 60 minus 30 is going to be 160 minus 90 is going to be 70. Firm 1's profits are going to be 70 minus 40, or 30 squared, right? Times the quantity 30 is 900. Firm 2's profits are going to be 70 minus 40, which is 30 times 15, which is the 450. So joint profits, just summing up industry profits right here, are going to be 1350. Right, and that's our solution for our Stackelberg problem. Okay, so we've reached the end. I'm going to go take out my contacts, and have a good night, everyone.